So my project is expanding green gate cloning, a modular toolkit for gene expression and functional analysis across multiple heterologous systems. So traditional molecular cloning techniques are time-consuming and labor-intensive, and they use an enzyme with great specificity that only forms one type of overhang. However, alternative molecular techniques, such as Golden Gate or Green Gate, use a type 2S restriction enzyme, which cuts outside of the recognition site. Green Gate allows us to assemble multiple modules, which contain our desired genes and tags in a predefined order using complementary overhangs. My project this summer was to take Green Gate and apply it to multiple organisms where a foreign protein is present, which are known as heterologous systems, which allow for more flexible cloning. So the first heterologous system that I used was tobacco. Tobacco injected with agrobacterium that had been transformed with our assembled constructs was used in order to visualize protein expression and localization. So here are the constructs that I created, which include MA1 and MA3. So MA1 is a membrane transporter, and MA3 is part of a larger protein scaffolding family that associates with MA1. Using confocal microscopy, we were able to visualize a red fluorescent protein localized in membranes in tobacco leaves that had been injected with MA3. The other heterologous system that I used was Xenopus laevis oocytes, which are frog eggs. Oocyte expression systems have different requirements than plant transformation vectors, which are typically used by Green Gate. These differences include a T7 promoter, a 5' UTR, a 3' UTR, and a poly A tail. We were able to successfully construct the module containing the T7 promoter and 5' UTR, but are actively still working on constructing the module containing the 3' UTR and the poly A tail. Injecting cRNA into oocytes allows us to look at protein localization and at interactions between proteins, as well as additional functional characteristics that can not be viewed in plants. Using this modular toolkit will allow us to greatly streamline cloning protocols, as well as expanding this technique to a wider variety of heterologous systems.
Thank you so much for sharing your work. This is super, super interesting. Very interesting about the eggs. Like I was not expecting that. That's really, really cool. So I would love if you could tell us a little bit about what your favorite thing that you did this summer, or the most interesting thing, or even like one of the most challenging things that you encountered during your research.
Yeah, of course. So I think my favorite two techniques that I did this summer were gel extraction, because it looks really, really cool and you can see bright orange bands when you're doing it under the UV. My other favorite technique was probably the plant infiltration. It was really, really fun, and you could see the color change as you were injecting the substance. Yeah.
Thank you so much. Yeah, super, super interesting. I really appreciate it. This is really great.
Thanks.